Welcome to the 46th round of the eBay Tech Talk. Today it is my honor to speak here to you about OpenShift. My name is Lutz Lange. I'm a solution architect with Red Hat. I'm working for Red Hat now for 10 years. And my main focus in the last 4 years was dealing with container technologies. You might wonder what the solution architect is. At Red Hat, this is something like a pre-sales consultant everywhere else. So I do explain our technology to customers and lately service providers and partners, mainly. So the title is OpenShift Container Platform and Enterprise Kubernetes Plus++. And I want to give you an overview, and we can have a bit of time to discuss things as well. The crowd is not too big to ask questions and get answers. So, who here knows what this is or has something like this at their company? Raise your hand. Well, for me at least, we talk a lot to bigger customers and partners, and the bigger a company is, the more pronounced this problem gets, because it is based on organizational issues first. So there is someone that develops something and throws it when it's done into production, and somebody else has to care about that. And this leads to a lot of problems and long release cycles and debugging issues. There is a wall of confusion because the dev doesn't know what is needed in production, and ops doesn't know what really to do with what they got. So sometimes this involves repackaging software and stuff like that. The first step to really make a difference here and make this better is break down this wall of confusion. This is basically what DevOps aims at, and it's the first step in a journey to make this better. It's a reorganization mainly to put the people in the same team and make them more effective, because they know what the other person's job is, what their requirements is, and they start to care even. So you might have heard the term cloud native and digital transformation. I don't want to dwell too much on it, but what I want to talk about from technical side here fits right into this scheme. So reorg, we talked about this a bit, breaking down the compartments and the walls. You might have heard of Conway's law, is the first step. But then you find out that a simple reorg is oftentimes not enough. You want to be quicker providing resources, so something like self-service offering, where you can get on-demand resources, automatic infrastructure as code thing might be needed and helpful. And I don't talk about the technologies. There's lots of different technologies you can use for that, but that's basically the same concept that you'll find in all of the cloud technologies. Then from an infrastructure side, and maybe even from a developer side, there's a need for automation, right? You have seen things like Puppet and Chef and Ansible, and nowadays even Kubernetes fits into this space. Okay, so it's orchestration needs, and it's IT automation that is at the center of all of it, has been for 20 years and more, and there's not a golden way to do this, because every company, every process is different. So but we're still improving on it. CI/CD and continuous deployment are terms that are often used with the software development. Maybe can I get a show of hands here? Who has a developer background in the audience? Okay, it's a rather big number. Who has more an ops view? Who would say he's DevOps? Okay, thank you. So there's more developers here, and we could later steer the discussion and what I'm showing more into this direction. My background is more from the infrastructure side. That's where I come from. But these concerns nowadays, they mix, as we've seen in the terms of DevOps. So CI/CD pipelines are not only something for software development anymore. These things come to running software and to the ops department as well. And then there's advanced deployment techniques. That's where you have had a long sit down with everybody, and your processes start to run smoothly, and you're quite happy with what you're doing, right? Yeah, and then there's this is where you want to get with using microservices and all the latest stuff. So this is kind of a journey that you can embark on, and everybody is somewhere else in a journey. I have later on another picture that that you can use to discuss this. But this is a slide. This has a few questions on it that make you think, that spell it out again. What we find lots of times when we talk with bigger organizations. So good question. How many days or how long do you have to wait for resources for a VM? So remember, VMs were supposed to make the whole wait for resources situation better. And yeah, they help. You don't have to wait like 2 or 3 months for resources. Now it's down to weeks most of the time, because there's still a lot of stuff to do, like firewalling, and the firewall department, they don't have an API and didn't automate the stuff. So that's painful. And developers, and not only developers, everyone who is waiting for this cannot be productive in the meantime. There's ways around this. I've seen ways around this. Developers ordering tons and tons of virtual machines beforehand because they might need it. This is one solution, but it's maybe not the ideal solution. So we talked about self-service. It's something great to use, really, if it's there and if it works. Something that is API driven, that you can program, and you don't have a ticket and a manual process in the end that somebody needs to do and to make this work. So infrastructure on demand is one of the steps that you take. And then there's another thing to think about, and there has been different terms to think about this. You might have heard of the pets and cattle discussion. There is something else, and it's the snowflakes and the phoenix discussion. So imagine every one of the snowflakes is a server or an instance where somebody has SSH'd into and run some script and changed some configuration. This is snowflakes, and this hurts you in the long run, and is not maintainable really. So what you want to get to is a state where you have phoenixes instead. Phoenixes are these beasts, these mythical creatures that can be burned down and they rise from their ashes. So this is what you need to design for if you want to be quick and if you want to be able to scale, really. So how you do this, I really don't care so much, but it's a feature of the stuff that you have built. Now we're coming closer to what I really want to talk about. This was more of stage setting, what I did just now. So there's a term on here, Docker, that probably everyone knows in the room by now. Who here has played hands-on with Docker? Okay, so that's good. I don't have to spend too much time on this, but mainly it's the packaging of the application together with the libraries as an immutable bundle. And this applies to the Phoenix concept, of course, which makes it then easier to roll out all the applications and not worry too much about dependency issues with the libraries and such. So what we use on for this as Red Hat is obviously RHEL, and there is a lot of different technologies available that are used to make this more secure, like SE Linux and SVirt to protect the resources. There's kernel namespaces, because these are all just processes, right, run on a Linux kernel. And there's the control groups to reduce the noisy neighbor phenomenon. Why are we doing container? There's another reason, and that is speed. This is just technical speed. So think about the max that the different technologies can do, like physical server. You can get that up and running maybe in under a day if you have the server already. Need to ramp it into the rack and so on. A virtual machine is technology-wise, it could be quick, but in terms of speed, a container is really a story changer, because it can spin up in the time that a request is started. And Google is mainly the main user of containers, or has been the main user of containers for long years, with their own tooling. And they start, for everything that you do, they start a container just for you, which is quite efficient as well. Why am I talking about Google? I'm talking about Google because they decided, like 3.5 years back now, that what they were doing with containers was so worthwhile, other people should do this as well. And they decided to open source the concepts that they have been using. They have an internal system that's called Borg to manage their containers at scale, and came up with the idea to start this Kubernetes project to rebuild that. So take all the experience that they gathered, put that into Kubernetes, start from scratch, make Kubernetes the better Borg. Because like every technology that has evolved over a long time of years, there's some quirks in Borgs that they wanted to get better with Kubernetes. This fell into the same time frame that Docker came around, actually. And we as Red Hat decided that we should put our platform as a service technology at the time, which was OpenShift version 2, onto a new technological footing, which means we used Kubernetes from the start, built that in, and Docker to renew what we already had. So this is an orchestration engine, which means it does all this what usually the ops guys do manually or start scripting themselves, right? And it has very far evolved now, and I would say, and a lot of people would now agree, that it has won the orchestration wars, if you might call it that. There's different technologies available. Docker Swarm, you might have heard of that. Mesos was another one, but no other technology has gotten that speed in development and new features and this big crowd around it. So what is OpenShift then? So OpenShift is a Docker runtime, it's a Kubernetes orchestration, and lots of stuff more that make this easy to use. Kubernetes is just an open source project, right? You can start and build a Kubernetes cluster same way as you can start and build your own Linux. It's possible to do that. There's Linux from scratch, which is a lot of guidance how to do this, but it's a lot of work. So what we sat down to was making this easier to consume. And this slide is just to show you what the difference is and what we add. I could spend like 15-20 minutes on this slide and talk about the different features and what they do. Just to give you an impression, there is lots of different choices that we make, choices that you would need to find solutions yourself if you start building your own Kubernetes cluster and put your processes on top. For networking, storage, for how to deal with logs, how to deal with metrics and stuff, security things, then how can I integrate that with my developer workflows. There's things that we have built, and we can spend time on this. I have a few other slides I would like to go through to give you basic understanding of what we can do and what this is and how it's built up. And then we can come maybe back to this or dive into different areas that are of interest to you here and today. This is another view for the journey that you can take in the different departments, in the different lines, if you will. There's applications you can look at, and the architecture of applications has changed a bit, at least if you write new applications, because the old ones are still lying around, of course. Somebody said writing monoliths is a bad idea. Let's structure that a bit better. And there's n-tier applications now where you have your front end, your middleware, and your back end. And the en vogue term now is microservices. Yay, everybody's doing microservices now. Who here is doing microservices? Quite a lot of you. Good. Of course, you have the developer background, right? You're writing this stuff now, but if you look at the applications that are out there, 80% or 90% are not microservices today. And these want to be run and hosted as well. So there's the infrastructure side of things, from the data center to something that is hosted, and then maybe hybrid architectures. I get a lot of questions about hybrid architectures or cloud native, cloud only architectures nowadays. Development processes need to align with that as well to be speedy, so smaller teams, agile development, DevOps processes. You run it, you own it, things like that. And this is a good slide to discuss this with companies that you sit down to where are you in the different areas, and then you can address concerns and start to dig deeper. But containers themselves do mean different things to different audiences. So there is the sysadmin and ops part, and for them it's sandboxed applications, it's denser packing, it's better resource usage and portability even. For developers, it's not just so much really a development tool, because containers don't have so much to do with the code that they write, but it's a packaging tool. It's something that makes it easier to deploy the stuff, to be quicker with that, to not wait on resources too long. And it's a technology that is capable of being run in different infrastructures as well, right? Because it's a container, it makes it more portable and scalable. I want to now go a bit deeper into OpenShift and talk about how OpenShift is built up and which sections of this OpenShift does address. So we have seen self-service is a good idea, and we do have a self-service capability. There's an API that we offer in OpenShift. It's based on Kubernetes. It's extended with a few features, and there is a web UI that you can use to access this. And I have a demo environment available. I can show you some things. It's multi-language. We don't have a focus on a specific programming language. There is a bunch of things that we integrate very well with, because we offer builder images for it. So a way to easily build container images for certain languages. Automation is at the center of all of this, of course. This is the Kubernetes orchestration features, and we have added on top of that as well to make it easier for you to deploy applications and roll back changes and roll out something that you had before. It makes it easier to collaborate if you have such a platform. Security is at the very heart of all of what we are doing here. If you go out to Docker Hub today and you grab an image and you run it, most of the time this runs as root. Is this something you want to do in production? Maybe not. And we do not allow that from the default setting. You can do this, but it's a cluster-wide setting you have to change, or not a cluster-wide, but a setting you have to change. It's hardened, there's a life cycle behind this, and we update this, and we have an upgrade path. Who here has run a Kubernetes cluster? Okay, a few of you. Updates is still something that is a bit problematic, what I've heard. So this is something that we design in. You can upgrade your OpenShift from one minor version to the next. Web scale, obviously, standard space. Standard space is actually a very important topic as well. Who here knows what the OCI is? The Open Container Initiative. There has been a lot of discussion like 2 years back when CoreOS launched Rocket. And there was a fear that we get into a situation like with the Unisys that were splintered off in different directions, not compatible anymore, and who would have benefited from these competing standards, right? They needed to be put into these competing systems because the standard is don't get me started on talking on standards too much. But we now have an OCI version 1.0 that is an industry standard. So there's in what the runtime has to offer, what the image has to look like, and things like that, which makes it a more secure environment to invest into, really. So there's different levels that we can look at. So at the most down level, there is the host, right? This is still a Linux. This is for us Red Hat Enterprise Linux, of course. And there's different options or variants. You can use an atomic host, which is a specialized version of RHEL that is stripped down to only allow running containers. Or you can use a full Red Hat Enterprise Linux. And it depends what you're used to. Most people and most customers that we have go for the full Red Hat Enterprise Linux variant nowadays. But we imagine that when the clusters grow bigger and bigger, this can lead to problems because this is not immutable infrastructure. While the atomic host can be run as immutable infrastructure for the host, which ties down changes and allows for better management and scalability. There's the container runtime and packaging, which is Docker. And yeah, we put something on top. That's the infrastructure level here. At the heart of it is a Kubernetes. The current version of OpenShift is version 3.6, and the .6 aligns with Kubernetes 1.6, which is the basis that is in the 3.6 version. So we lag a bit behind, but it's only 4 to 6 weeks until we have the newest version in nowadays. And then there's networking. We have a certain, we have one default networking, SDN networking built in. There is choices for networking that we can talk about and have a slide later on. There is choices for storage that are supported here and are available. This is the storage mainly that I'm talking about that you provide for your workloads, for your pods. So persistent central storage. There's a registry already. You need something to put your images. So OpenShift comes with a default registry, with a secured registry. And you can only access that if you have a token. And a token you can only get if you authenticate it. There are solutions for logs and metrics as well. So in a containerized environment, how do you get to the logs of your workloads? Something you need to find a solution for, and we have one in. It's an Elasticsearch Fluentd Kibana combination that we are using that runs Fluentd on the hosts, that gets all the log messages from that host. You have to build your workloads in a way that they put out every log message onto standard out when they run. And then sends that off to Elasticsearch, and you can use a Kibana interface to look at that. There's a metrics solution as well. Metrics is where you look at counters, like how much CPU, how much memory have I used, what's with the network bandwidth that is used, things like that. It's also important for different reasons, like if you want to bill a customer for using this environment. One reason, right? Or just debugging things might be interesting as well. There's a Hawkula, Cassandra, Heapster combination stack that we have for this. And then there's security stuff. We have a role-based access control mechanism. You can really tie all of this down. There is quotas that you can put onto projects. Projects are used to organize all the objects in the cluster. Users get access to these projects. The projects can have a quota, and if I want to really use it, then I need to limit my workloads so that they can only use certain amounts of resources. This is under the hood then implemented with C groups, and so that's what you can do for resource management, for example. On top of that, we put tools that are addressing the cloud concerns that we had before, that are mostly found in the developer space, and for a long while we positioned this as a solution that addresses developers first. Now it's for developers and for production workloads. So there's the self-service that I talked about, there's a web UI and the API. There is a service catalog that is mainly a feature where you can put in workloads that you can order from. So there is a template mechanism, for example, that allows you to group all the objects that you need to run a workload, and it can be a complex workload, a multi-container workload that needs services, routes, IP addresses, stuff like that, configuration files, and that can then be ordered from the service catalog, from the API or from the command line or from the web UI. It's called templates. It's something that Kubernetes does not bring out of the box yet. We have revamped the service catalog even, and I can spend more time on that later if you want to. We just announced a tech preview feature in 3.6 that you can look at, that makes services more powerful. Another thing you need to think about is, where do I build my container images? And one option that you can go for is you can do it on OpenShift. You don't need to do it on OpenShift. If you have something already, you can continue to do that. We do have something that's called source to image. I do have a slide about that later. There's a deployment automation that I mentioned already. So every time you deploy an application, it gets recorded what the configuration was, and you can then later on decide to roll out the version that you had before. It's always an ongoing deployment, so you can't not really go back, but you can go back to a deployment version and the configuration that was before. We do have CI/CD features in. This is mainly an integration into things like Jenkins. So there is a Jenkins integration. You can run with your company-wide Jenkins installation, or you can run Jenkins in OpenShift. And see what's going on in Jenkins in the OpenShift UI, for example. So this is a source to image walkthrough slide, and it's a specialty of OpenShift. It's something that nobody else has, so far as I know, and it looks like this. So there's a developer. The developer does what he does on his notebook, and at a certain point in time decides to commit code into Git. You do have a Git somewhere, and you can configure the Git with a webhook to inform OpenShift there is new code. So OpenShift gets informed there's new code and can then start, if it's configured that way, to get a builder image from the registry and schedule that builder image into the cluster. Builder image is started with a parameter that points to the GitHub repository where the code is, pulls down the code, runs its magic. There's scripts in that can transform that source code into binary code, and in the end add an additional layer on top of the builder image and commit that back to the registry. So if that is back in the registry and your deployment is set to watch the image streams, as we call it, and has an image change trigger, then a new version of your application can be rolled out automatically. So your old application can be running and can then be replaced. And there's different strategies that you can use to replace that, which is quite nice to have for agile testing things. And so this is the stack, if you will. And on top of that, you can put your own workloads and applications and containers, and we as Red Hat do that as well. So all of these are already on OpenShift and available on OpenShift. This, for example, mobile platform, Feed Henry Base is the open source project of that, was only available as a web-based, a cloud-based service. We have made it available on premise now, but you have to put it on OpenShift. Yeah. So with that, this is the architecture overview. Here's a lot of different boxes here, and I will spend the next 10 to 15 minutes going through the different boxes and explaining what these do and how this works. Some of you here already know Kubernetes, so these concepts might seem familiar, and they are. So OpenShift runs anywhere. You can run a RHEL x86-64 because that's what we have tied the Docker support to. Docker support, be careful with that because you have to use the Docker that we ship. There's different Docker versions. There's Docker from the company Docker, and there was a project, a community project called Docker. It's not called that anymore. It's now called Moby. And we do run the hardened community code. We do have a few patches in that Docker wouldn't accept, but were necessary for making this work in a good way. Anyhow, you do have nodes. Nodes is where your workloads run then. So the applications that you want to run, and these run in things. These are called pods. There's specialized containers called pods in Kubernetes, and you can run one or multiple containers inside one pod. The pod is the atomic scheduling unit. So this is what Kubernetes sends out to the different hosts and watches then the containers inside. And if one of the containers inside the pod dies, then it is rescheduled, for example. The pod is also that what gets an IP address. So if I want to run a container image, then container image is put into that, pulled onto the node, put into the pod context, so into container context and into the pod context, and it runs on the node. So I've said that already. We do have a few more icons here where you can see Tomcat and the MongoD and other containers. There's a MySQL down there, whatever you want to run. There's a control plane involved as well. This is called master. There can be one or multiple masters. Masters, well, the master controls the environment. There is a bit of overhead, of course. So the API service, API server, runs on the master. This is what everything talks to when it wants to do something in the cluster. We do have a command line utility. It's called OC. It's an extension of the kubectl, you might know. The web UI talks to the API, and you can talk to the API directly with whatever tools you have. Then there's a data store. Everything in a Kubernetes-based environment, and nowadays in cloud environments, is done with these key value objects that are in JSON or YAML. I found that in the beginning there was lots of more JSON. Now people do YAML. It's better readable than JSON, human readable, I think. Though you have to be careful with the formatting, right? With the indentation. That's an etcd that runs there. There's a registry. I mentioned that already. Registry is shown here as standing on the side, but really it's running on a node as well. You can run it on the master, run the master as a node. There's a node service that you can run there and put the registry in there if you want to. So it's an architect choice where you put it, but you do have to run an internal registry. There's a scheduler. The scheduler looks into the data store and sees the objects that are there, and scheduler looks into the environment and tries to make a match. So there's a policy behind as well that deals with issues like placement and so on and so forth. But one of the core techniques is that you specify what the world should look like or your environment should look like, and Kubernetes will make sure that it gets to that state. So starts or stops workloads, for example, is one of these issues. Placement is determined by a policy, and policy can look at labels, for example. So every object that you have can get a label. This allows you to control where workloads are placed, for example. So you could run an OpenShift as a dedicated environment, meaning for just one user, or you can run it in a multi-tenant fashion where you have multiple users, and maybe you want to decide that a certain user's workloads are only placed on these two nodes and nobody else goes there. Would be something that you can do by using labels in a clever way. Then there's health and scaling mechanisms available as well. So I said it's an orchestration mechanism, and one thing that IT department needs to make sure is that workloads keep running, and if something fails, they need to repair that. This has been a manual job in the past a lot, with much of what's the word? Where you get a pager and are called in the night? Yeah. So we don't want to do that. And you, as somebody that builds workloads that run in this environment and that know your workload, what you can help here, because it's your task to define health checks. Only you can really know what the conditions is under that you would say your application is really healthy. And you can provide that information to the outside so that it can be checked. A simple web call could be enough that returns success when everything is good and an error code if it's not. And then the environment calls, so the OpenShift cluster calls these health checks in a certain schedule, and if these fail, then the environment can take action, like restart that workload, migrate that workload, restart it somewhere else. And this is something that the that OpenShift does for you. So there's a service layer. Service layer, what do I need that for? The service layer is needed for the communication between different pods. So back in the beginning, when Docker was quite new, everybody said, well, wow, this is so such a good technology. I can put my application into the container and then I schedule it somewhere and everything's fine. And then people started doing that, and suddenly they realized maybe I need more than one container. And that's where the problem started, because these need somehow maybe to talk to each other. So there is a network in between, hopefully. What kind of network? And how do they get the IP addresses? I can hard code that, but then it's not scalable anymore. We do have a networking in between here, our default SDN solution. Is it interesting to you? Okay. So this is, in default, it works like this. The whole cluster gets an internal IP address range of a B cluster of the B network, class B network. And then the nodes get assigned a subset, a class C network. Every node gets a class C from that class B network. And when a pod is scheduled onto a node, it's assigned an IP address in a dynamic way. So it doesn't know beforehand which IP address it gets, but it gets one. So if I have a Tomcat and a MongoD and these need to work together, then I need some kind of mechanism so that they can find each other. And we do have something that is not on this slide here. It's DNS, a Sky DNS here, and a service layer IP network. That's a class C network, I think, in the default, which can give out cluster-wide IP addresses, service IP addresses. I define, if I want to be reachable from other ports, I define a service object. The service object gets a name, like my Mongo, for example. And when I define that, I reserve a service layer IP address with that my Mongo. So this gets then resolved from my Sky DNS. If my Tomcat wants to talk to my Mongo, it just opens a connection to HTTPS, for example, my Mongo. This resolves to the service layer IP address, and the service layer IP address is reachable from every port through IP tables DNet magic that happens. So this is what we do internally. Still not reachable from the outside. It's all internal. It's a security mechanism. There is persistent storage. In the beginning of OpenShift, in the beginning of any cloud technologies, it was always that these are for stateless workloads, right? Something which can die and restart and doesn't need any storage. Nowadays, we found that there's lots and lots of applications that are different, that need storage, that are stateful. So we have a mechanism now to provide central storage. Different storage technologies. We can talk about that later as well. The first one was NFS, but we're past that. We can do other stuff now. So access from the outside. Access from the outside is done through a routing layer. So another of these objects that go into the etcd. And it's implemented in a way that when you set up your cluster, you delegate or you set up a wildcard DNS domain. Everything under appsexample.com is then passed on to your routers. There is a router component that you deploy, and it's an HA proxy container that runs and is updated every time a new route object is created in the environment. And this then allows you access from the outside. You get a name, an application name that you put into your browser, for example, and this brings you to the routing layer. And this then knows which service is meant, and through this, okay. I don't want to make it too complicated. It's implemented a little bit different, but it goes through the routing layer and the service layer informs the routing layer which ports these endpoints have. Okay. This is the basic overview of how OpenShift works. And then there's people that work with that. It can be developers with their source control mechanism and their Git and their external pipeline and tools that use this as a platform to dynamically get resources they don't have to wait for. Or it can be operations, right, that run production workloads in this. So I do have more slides, a few more slides to take more looks at the infrastructure. I have one slide here that is for the software-defined networking, and there's different models available. What I just talked about was the flat network option. In the flat network option, every port could theoretically talk to every other port in the cluster. A lot of customers don't want that. They say it's not good and we need more separation. There is the multi-tenant network option available for a while now, and this allows for separation of projects. So each project gets like their own VLAN and is boxed in. and they can only reach the default namespace or the default project. There's a default project in OpenShift where central services run, like the internal registry, like the router, things like that. That needs to be accessible from all the projects, but your workloads don't need to be accessible from every project. So in this diagram, project C stands alone. You have the option of joining projects and make the different workloads available to each other in a project, but that's what the multi-tenant network can do today. And you can basically use that in multi-tenant cluster situations to separate the network traffic. Still, for some, this is not enough. Especially security sensitive industries like finance, for example. They want something even more granular, where they can then specify exactly which connections are allowed, and everything else just doesn't work. This is in the making. It's currently marked as technology preview, and yeah, will come in the next version probably. You can take a look at it today, but it's not really done yet. That's every time we say technology preview, this is something that is still evolving. And then there's people that say, well, I do already have an SDN. I don't want yours. It's possible to do that as well. This is a list of plugins that are certified or validated against OpenShift. This is not something that we as Red Hat support. We just support the API for it until the other software vendor gets in, and they then use their technology as well. So Flannel is not really a good option. This is something that you can use in combination with OpenStack, because you get double encapsulation in that. Nuage, Tigera, you can read it yourself. There is options. Another thing, I have one slide in my main deck here is persistent storage. Persistent storage is an important part of applications, especially if you want to use this platform to run stateful workloads that run longer than just a few days, or longer than just for testing. And the platform is destined to do that. And there is NFS. We started out with NFS. There's Cluster-FS, which is software-defined networking, and also the basis for our container-native storage. I can talk about that a little bit more if you're interested then. This is running Cluster inside of OpenShift as well. Then there is storage that is dependent on the architecture that you deploy OpenShift on, like OpenStack Cinder. You have to deploy on OpenStack for that, or AWS EBS, the Google Compute persistent disk, Azure disk, Azure file. There is Ceph, but only the Radas block device currently. There is technology-wise a Ceph file system that's not done yet. So we're not confident enough to say this is a technology that you can reliably put your data on. This takes a while longer. iSCSI, you could do Fiber Channel. I'm not so sure if Fiber Channel is the best option for this. It's not so flexible in my experience. It needs a good API then, because the way you use this storage needs to be in a self-service way. Really. And if you looked at the development of the persistent storage options in the last two years, in the beginning, an administrator had to chop up bits of storage and create physical volumes and make these available in abundance in the cluster to be chosen from when needed, which was really a bad choice, because you can't match your requirements in a very good way. So maybe you have 10 gig volumes, lots of 10 gig volumes available, and then comes a claim for like 1 gig, and yay, I found Kubernetes or OpenShift found a match and uses this volume, and you have lots of wasted storage that you don't really request it. There is a mechanism now that's called dynamic storage provisioning, and this fixes this. So there is a physical volume claim object that somebody who needs storage would write to request storage, and there is with cluster, OpenStack, Cinder, AWS, these and these, I think at least, there is a way that a volume can be created on the fly in the right size with the right specification. Now it is. Yeah, it's storage. And there's lots and lots of reference architectures that we have. So in terms of products that we have, emerging products as we call it, OpenShift is the most successful one. And I think there were lots of technology hypes in the past few years. And for quite a few of them, it turned out that it took quite a long while to get to a state where it's really usable and more companies and people use that. OpenShift Kubernetes is on a fast track. It's has surprised me how quick adoption of this is. Yeah, and so we came up with lots of different reference architectures. This is where our engineers sat down and wrote a guide, a best practice to how to deploy on or do OpenShift on a certain infrastructure. These are all links, and you will get the slides afterwards. This was my main slide deck. And we do now enter the discussion section of the evening. I have more slides, or I can do a quick demo if you're interested. I see nodding heads with a demo, and we try that. Not sure if that works. I didn't test this screen setting before. Something works. Okay. Good. So this font is too small. Let's change that. No. Let's not change that. So this is a cluster. I can show a bit of the infrastructure as well that I'm using here. So I do have this running on the Google Compute Cloud. There's different options to run OpenShift. You can even run it on a notebook, and I can talk about that a little bit. It's quite easy to do for testing purposes. For these kinds of demos, it's sometimes interesting to see more complicated stuff and how this works. So I have an installation that runs on the Google Cloud platform, and for talks like this, I spin that up. So there is one master and 3 nodes in my setting here. There's some kind of bastion host that I put up as well. For a production environment, we do recommend a fair amount of resources just to make sure that it runs smoothly. And if you decide to deploy the logging stack or the metric stack that I talked about, please do reserve special nodes for that, because this needs some juice to really work. In my case, I decided to go for 8 vCPUs and 30 gigs of RAM for the master, and I did design the nodes a bit smaller. These are 2 vCPUs and 7.5 gigs of memory nodes. There is the part with the DNS that I can quickly show you regarding network. There's a cloud DNS. So what I did is I transferred a domain that I have into the Google Cloud. This is a bit too small, isn't it? And you can see it here. I do have, for example, here the wildcard domain, star apps OSE SA demo.de, and this points to the fixed IP address that I have on the master. I run in this set up in this architecture my router on the master. Might not be the best way to do it, because if your master goes down, all the applications can't be reached. And I only have one router for an HA deployment. You might need two at least. But HA design is something that you can choose to do as well. So I already connected to the web interface. This is the web UI of the 3.6 OpenShift. This is mainly the user view. As a new user, you get shown this rather empty screen, and you can say create project. Projects are extended namespaces. So in Kubernetes you have these namespaces, and we put a bit of stuff on top and called it project. And I call that eBay test maybe, and only small letters. Yeah, I keep forgetting that. eBay test, and call that eBay Tech Talk. So, and then I hit create. So now I am sent to the, I call it legacy service catalog. We do have a new one, and if we're lucky, I can show you the new one as well. So this is where we have the templates shown that are available, and I can choose from these. There's languages. Languages is the source to image builders that I mentioned already, and I could quickly select one and do a quick example, like the Ruby one. So I do now get all the templates that are connected with anything with Ruby. There is the Ruby S2I builder in the corner here, and then there's a Ruby with a Postgres, with a persistent Postgres. So I need a persistent volume on that, and there's an ephemeral version as well. I just go with the Ruby. There might be different versions available. This is all done in image streams in the background and handled in image streams. I select this, and so this is a test Ruby. You see I have tested it before, if it really works. And you give, besides the name, you give it a GitHub URL where there's source code. And we do have some samples provided, and the sample is quite enough. For us here, there's advanced options that you could do, but I just hit create. So if I hit create, I do get displayed a bit of information what I can do as well. So to manage the OpenShift workload in from your notebook maybe, or from any station, from the command line, you could install the OC client. It's something you can run on your notebook and manage a faraway cluster. All you need is access to the API port. And the other thing is about the how to configure the webhook trigger if you want to do stuff automated, in an automated way. Let's go to the overview side. This is the overview, and all workloads are now shown in just one line, and I can open that to see more details about it. We do enhance the web UI with each minor release and do amazing things, really. I'm surprised each and every time. So now what we can do is we can, in this overview, if I expand that, see the logs of the build. So the builder image was scheduled into the cluster, has downloaded the source code, and is now compiling the Ruby stuff. What we have also gotten is, we see it on the top here, a route. This is a route object. There's the clicker. So this route now is called test Ruby minus eBay test at apps ose.srd.de. You see what happened here. The name of the app is comprised of the app name and the project name put together. That's the default. And once this is done, the build is done, and it's in the last stages here where it's pushing the image layers after successful compile into the internal registry. Then the image is scheduled into the cluster and run. The application is really run. And I can then click on the route to access the application. So this is what's happened now. So the rolling deployment is pending. Rolling deployment would mean that running workloads would be exchanged if something else would be running. And what else I can do here is increase the number of copies, for example, just by pushing up these arrows and buttons. This is information about how much memory, CPU cores, and so on is used. I don't have that yet. My metric stack needs to watch this for a while, and I want to display something. But we can go to the pod, which is interesting as well, because this is your workload, and this is where you might want to do debugging and things. So I said I have 3 nodes. What I see here now is it runs on OSE node 1 on the first node, and that's the IP address. It's ready. Restart count is low. Something to watch for, because if something is wrong, the environment would start restarting the workload in longer and longer time frames if things can't be fixed. So if you watch the restart count, you see there was something wrong, or there is something wrong, and I need to do something. There's actually events that you can now watch in this environment as well. This is the image that we're running. This is the build. There is a security token that is mounted into the pod context as well. These are only transferred in an encrypted way. Never reside on nodes, for example. There is things like the environment. This allows you to specify like environment variables or config sets which can be used to configure the applications that are running in the container. This is immutable infrastructure, right? So the container gets built, container is never changed, but somehow you want to change settings, and this is done through these environments. For metrics, I don't have the information yet, but this shows me that the metric stack is up and running. We can go back there later. These are the logs on the standard output from my workload. Not much done yet. Another thing which is quite helpful from time to time is the terminal. You do get a terminal here into your running container workload. There's an additional bash process that is started in the container context. I could do stuff like look at the Red Hat release. This is 7.4 based. And then there is the events that you can watch if you want to know what's happening in your environment. Pulling is the Docker image. You can see how images are specified. There's an SHA-256 sum that uniquely identifies each of these images. Okay. Let's access the workload maybe. That's an idea. It's not that fancy really, but this is what was built. I could have chosen another repository or another application. We do see now that there is memory usage and CPU cores and stuff, information about that coming along. What else is interesting? Maybe there's other things that you could choose to do, like deploy an image. If you have an image, you can run that image on OpenShift, provided it is OpenShift, built for OpenShift. So there is no user statement in your Docker file, and stuff can run as non-root. Otherwise, you have to change your settings here. All of this can be done on the command line with the OC tool. Yeah. Okay, I can repeat that as well. So the question was if there would be something available for having an OpenShift playground starting without setting this up yourself much. There's different options. So there's some things you can do on your notebook. Is that something you're looking for? Or would you?
Setting this up on my notebook is more of course, yeah, so I have to do this, but if there's something, I don't know, online.
It's actually not that much work. I show you quickly something what I've been doing. So GitHub, I do have a project on GitHub, and there is a tool called CDK that you can use, and all the setup that you need to do is run one command. So this is a shell command that in the shell script that you can run on macOS and on Linux. That's why I have this tested. This would then download roughly 460 megabytes of data at first, which is the CDK. It's a nightly built version that I'm using here because I wanted to look at the latest features. And then there is a command, another script that I have set up, which would then allow you to install a lab environment if you want to do this. There is then completely set up all-in-one installation where you have, for example, a registry console with, I didn't show that yet, this is an option you can install in the cluster as well, have a graphical interface into the registry, the internal registry, and look at that. We didn't talk about CloudForms, for example. CloudForms is our management UI for OpenShift. So this would access the metric stack, for example, or allow you to do container scans. We didn't talk about software lifecycle management in a container, which would be another topic that we could go into if you're interested. You can also go to developers.redhat.com. Sign up there for free, download the CDK yourself and do this in a manual step if the automated magic that I do here is not for you. There's the open source variant called Minishift available for doing this on a notebook. There is OpenShift Online as a cloud service that you could sign up for, and you get limited resources in that cloud for free to test it out. And there's test drives available with the cloud providers where you can get your own OpenShift cluster for a limited time. I think these are all that come to mind. There's some people don't want to use another virtual machine. So Minishift and CDK would start the all-in-one cluster in a virtual machine on your notebook. While there is another option that is going container only, and it's called OC Cluster Up.
All right, I'll give this a try. So first of all, the command lines.
Yeah. So this is I can put the link in a mail maybe, and send you that. But please give me feedback. I'm testing this out. There's still sometimes things that need to be improved, but I found that it's quite reliable now. It takes like if you're on a fast internet connection, depending on the lab you choose, this one, the download takes a while, but the OLAP command takes like 5 minutes, and then you can connect with the CDK console to your all-in-one cluster, which would actually be the option to show the service catalog that I mentioned, the new service catalog. Other questions?
I want to ask two questions. The first question is about the registry. Is it something that I get when I start the OpenShift?
Yes, the registry is included. It's an integral, it's a part of OpenShift. Every OpenShift cluster has an integrated registry. You can even run the registry as a separate enterprise registry in an all-in-one cluster fashion if you want to. Sometimes this makes sense in bigger environments.
So if I have my own registry already, I could use it as well.
You can use your own registry. It would run outside the OpenShift, and you can then point OpenShift at that registry. And even OpenShift is capable of following images in that registry itself. So if you update an image in your external registry and have your OpenShift set up in the correct way, OpenShift realizes that, because it would then check every 15 minutes or so if the registry has a new image.
My second question is about the persistent storage.
Yeah.
Is it something I get with the cluster, or is it something I should have provided in advance outside the cluster?
For persistent storage, you have to provide some kind of infrastructure. You have to make a choice as the one who is setting up the cluster, what kind of persistent storage you want to support. It depends on where you have your cluster, for example, but also on the whole architecture setting. So for service providers, for example, that want to run a consistent OpenShift setting for all their customers in different architectures, there's choices like Cluster, for example, that is architecture independent. That would make sense to deploy.
I mean, if I want to choose Cluster FS, I need to set this up aside.
You can. So the Cluster FS is a technology that has a specialty to be able to run inside the OpenShift cluster as well. It's called container native storage in that case. That would be you dedicate 3 nodes of your cluster for providing the cluster storage to the whole cluster. And then there would be 3 cluster pods running there that span a volume across some kind of storage that is in the nodes or connected to these nodes. You had a 3-way copy of your storage this way, which makes it secure. But there's also other technologies available. So if you in a smaller environment and you don't need that robustness, you can choose, for example, NFS, which is also architecture independent, but it's not as easy to secure.
What if I want to run other software like images from the Docker registry and want to customize them via Kubernetes primitives, like a config map or something? How would I do that in OpenShift?
So the challenge here is that most of the images that are in Docker Hub are not out of the box compatible. So you would probably need to customize these to get the sources, get the Docker file, and then build them in an OpenShift compatible way. The first thing to think about is that they can't run as root. Then there is things that you need to think about. Some software needs to be able to resolve the user that is it is running as. Then there's primitives that you build into your image building process to make sure that this fits. And if you're at this stage that you're rebuilding the image, then you can also include things like config maps, for example, to be able to provide configuration from the outside. You would need to include a way to access the data that is configured through the config map into the image. Same as with the environment variables, right? So if you provide environment variables, your scripts that are run and start the application then inside the container need to evaluate this, right?
Is there a pure Kubernetes endpoint I could use? Or is there only the OpenShift API endpoint, which is exposed?
The So there's a kubectl command, but it's a link to OC. You will find that a lot of the OpenShift things are compatible to what you do in the Kubernetes world. There are some things that are special. Most of the time it's things that we developed because it was not available in Kubernetes. And if you watch OpenShift for a while, you will see that we migrate to the same concepts once they become available or ripe enough in Kubernetes. So we go back to the upstream. We push our things that are special in OpenShift. We try to push that into Kubernetes as well. So we're after Google the second most active contributor to Kubernetes.
Thanks.
Any other questions? Hello. I have a basic question. Is Docker a hard dependency? Because Kubernetes is basically built in mind that you can also run different container technologies. So.
Yeah, a very good question. So I talked about the OCI in my presentation, and technological-wise, it's today not a very hard dependency anymore. The technology is there to roll out OpenShift with another container runtime today. It's possible, but it's not yet done and perfect. It's in development, and you can expect alternatives to become available in the future, and someday supportable in the future. But there is, in the supported sense, there is only the Docker that we ship. That's today what there is. But if you look upstream, development is already going on to enable other runtimes. There's a CRI that you obviously talked about or were thinking about, the container runtime interface, which was added to Kubernetes by the effort that the CoreOS people did mainly. They tried to integrate their Rocket runtime into Kubernetes and found that the Docker was quite hardwired. So they added the container runtime interface. And this now allows for a pluggable scenario where you could bring other container runtimes into Kubernetes clusters. And I imagine would still take a bit before this comes to OpenShift in a supported way, but I imagine it goes there. Yeah.
Anyone else with a question?
Who are customers of famous companies?
So the question is, which famous customers do we have? Oh, there's nowadays quite a long list. Let me quickly grab one slide because this could illustrate that quite well. So there's we do have lots of interest in this, and there is customers we do have reference stories with, and these we can openly talk about. The others, it's not that easy to talk about. So let me quickly. Oh, you're seeing this already. Yeah, I've shared my screen. This is one big slide where we have tried to show a bit how many customers these are. There is an organization called the OpenShift Commons. You might have heard about that. There was KubeCon last year here, and we did a Commons gathering as well. There were over 250 people there. So these are names of companies that have reference stories with us. So there's documents you can read about their use case and so on. There is a few more. So Amadeus was one of the bigger ones, French, European customer that decided quite early on to go for OpenShift for their new environment. If you don't know Amadeus, when you book flights and hotels and things, your transaction most likely goes through their systems. And they sat down and dedicated developers even to help build OpenShift in a way that it makes sense for them. There is yeah, there's a few others as well. These here on the outer fringes of the OpenShift galaxy are all companies that have signed up for the OpenShift Commons. So there's briefings like twice a week now for OpenShift topics that are broadcasted and saved to YouTube, and you can watch all the new cool things. So it's interesting. I have more slides about this. If you're really interested, come see me afterwards. I can point you to more reference stories and talk about that more. One other thing, I wanted to mention this because it is quite interesting. In terms of commons, there is a German organization as well. It's called the Anwendertreffen, OpenShift Anwendertreffen. There is actually next week on Monday is the next Anwendertreffen in Frankfurt, and we do have over 100 people that we're expecting there for a whole day of talking about OpenShift. These meetings happen like 3 times a year. There's meetups springing up dedicated to OpenShift as well. There's one in Stuttgart. There is one, I think, in Dortmund. And we're probably starting one in Berlin as well in October.
So thank you, Lutz Lange, for being here. Thank you all for attending, and please dig in. We have a lot of bagels, and thank you so much for being here.